Hey guys, welcome back. This is 5-3. We are solving logarithms, and we can't spell obviously because there's an A in logarithm. Alright, so do not rush through this unit 5-3 and 5-4. You need to understand what you are doing. If you have not completed 5-2, I recommend you go back and do that part because you're going to have to apply it in 5-3. Okay? Alright, so let's go ahead and start with our warm-up. It says to condense each expression into a single unit, so that means log is going to be written one time. Before you start, make sure the bases are the same. See how you have the same base? So the next step, see how you have a 6 here? Move it and let it become your exponent for A. This group goes together. That 3 becomes your other one, okay? We are going to condense. Notice there's a plus. What corresponds to a plus? Multiplication. So before I start, I'm going to write log base 8a to the 6 plus log base 8b to the 3rd. You could actually skip this if you see what you are doing. Now that plus right there, I'm going to rewrite because the bases are the same. So it's log base 8 a to the 6 times b to the 3rd. You can also write it log base 8 a squared times b, all of it raised to the 3rd. 2 times 3 is 6. There's a 1 here. 1 times 3 is 3. Both of these are exactly the same answer. Both are acceptable. Okay? Your next part, you are expanding. You're going to make it bigger. So log is going to be written many times. Notice this 1/3, this 3 right here, I'm going to rewrite it as log, there's no base, that base is a 10, x to the 1/3, y to the 1/3, z to the 1/3. Or you could also rewrite it like this. Log base 10 of x times y times z, all of that to the 1/3. These are exactly the same. So now I'm going to expand. So I'm going to make it bigger. Okay? Log's going to be written quite a few times. Alright. So log base 10, you don't have to write. X to the 1/3, what goes with multiplication? Addition plus log of y to the 1/3 plus log of z to the 1/3. And guess what you do? You kind of flatten it, so you have to move your exponent to the front. So now it becomes log of x plus 1/3 log of y plus 1/3 log of z. You could also, if you had used this one, you can write it like this. 1/3 parentheses log of x plus log of y plus log of z. Both of these are acceptable answers. Either one, okay? All the same. And all I did was factor out 1/3. That is your warm-up for 5.3. Alright, key word here, it says solve exponentials and logarithmic equations. So we're going to solve. And when you solve, you have x equals something, or y equals something, or a variable equals something. Okay? You're going to solve. You're going to have to represent numbers. So students will be able to solve exponential and logarithmic equations using properties of logarithms. As I stated, if you have not completed 5.2 or 5.1, you need to do that now. Alright, in order to solve, here are some rules that'll help you. Step number 1, rewrite using logarithmic properties and solve. So basically, you want to condense them as much as you can. If it can be written using the same base, use properties of exponents to simplify the problem. Solve by isolating the variable, okay? And there's your power chart again that you might want to refer back to. You are more than welcome to fill this out again, and if you're good, you don't have to do that. But you should have had this on 5-1. Alright, so changing of base. Example number 1. When your base is the same, see that right there? My base is a 5 and 5, okay? Notice the equal sign. equal signs are very, very important. 5 of x is equal to 5 squared. See how the base is the same? The base cancels out, and you bring down your exponent, so x is equal to 2. You want to check, x is 2, right? 5 squared equals 5 squared. See how they're exactly the same. Okay? You have a question, honey?
No.
Okay. All right. Oh, the chart is up there if you need the chart. You might want to move for encryption. Okay. All right, let's look at the example 2. Notice x and x minus 5 is up there. X are your bases. Cancel those out. Only if there's an equal sign. If it's not an equal sign, do not cancel them out. So now you have x is equal to x minus 5. Solve for x. Minus x minus x. That cancels out. So you got 0 equals to negative 5. Do you have an answer for that? Nope, this one is a no solution. Okay? Because when you plug it in, it doesn't work. All right. Example 3. Now let's take a look. Okay, your bases are not the same. All right. Sometimes you have to change the base. I have to go grab the sheet. Okay. So if you take a look, here's the sheet right here. 5 and 125. So look at column 5. You guys see that? Notice there's a 5 here and a 125. Okay? Keep that in mind. So I'm going to rewrite. I'm going to change my base. 5 to the first power, x plus 2, equal. Notice the equal sign. Instead of writing 125, I'm going to replace 125 in exponential form. 5 to the third. You guys see that right there? Why did I do that? Because now I have the same base with an equal sign. So they can cancel out. 1 times anything is itself. So now you have x plus 2 is equal to 3. How do you solve for x? Minus 2 minus 2. So x is equal to 1. Okay? Let's check. 5, x is 1 plus 2 is equal to 125. 5, 1 plus 2 is 3 equals 125. 5 to the third is 125. Do you see how that checked out? Just like that. Okay? Next one, 36 and 7,776. Well, I don't have 36 in my power chart because I only went up to 10. However, 36 and 7,776. Do you see how it is located right here? Okay, so instead of writing 36, can I rewrite that as 6 squared? Bring down your x equals, because that's 6 squared is the same thing as 36. How about 6 to the 5th instead of 7,776? Same base, so now you got 2x equals 5. How do you solve? You divide by 2. X is equal to 5 over 2. Or you can have it as 2.5. I prefer fractions. If it's a decimal, it better be exact. Oops, sorry guys. There you go. Okay. So this chart right here comes in very handy, which is the same chart you have on your first page of your notes. You might want to use that. All right. And then I'm going to take a picture of this and put it in Google Classroom also, so you guys will have it, okay? All right, so that's changing the base. Equal sign. You have to have that between the two. All right. Now, example 2, converting to a logarithm. Okay? Sorry, guys. I had to go close the door. Okay, now you have a 10 and 60.5. Notice there's nothing on that chart that has that. So I'm going to rewrite it. Remember, b to the x is equal to y. I'm going to convert it to log. Base goes here, the y goes here, and there's your x. Okay? So here we go. What is your base? I'm going to rewrite this as a log. Log, my base is a 10 of 60.5, and if you need to put parentheses around it, please do so, equals x plus 10. Okay? How do you solve for x? By the way, these guys, do not separate them. Keep them together. Minus 10, minus 10. Okay? Watch how I type it. You guys ready? Let me get out of that. Let's go ahead and clear this calculator. Perfect. Okay. The button for log is right here. Do you see the base 10? So you can just go 10, base 10. You don't have to type it. Remember, it's understood. 60.5 in parentheses. Keep it together. Minus 10. And your answer comes out to be x is equal to negative 8.2182. 4 decimal places will make me very happy. Okay? Awesome. You guys good? All right. Now let's take a look at this one. This one has an e. Okay, so we're going to rewrite it. Log base e of 99 is equal to x minus 10. All right. Now, I'm going to point something out. Anytime you have a log base e of x, that is the same as natural log of x. You're replacing log base e with natural log. Why do you want to do that? Because it is so much shorter to rewrite it. Okay? So I'm going to rewrite this as natural log of 99, and if you need to put parentheses around it, you can, equals x minus 10. How do you solve? Add 10 to both sides. Okay? So let me show you how to do that. See the button that says natural log? Right here. So natural log, 99 in parentheses plus 10. So x comes out to be 14.5951. Your answers will be in decimals. Okay? All right. 4 decimal places, I'd be very happy. Okay, let's look at the next one. Now keep in mind, notice what's the same. You see this right here? You want to isolate that base with the power. So what do you do first? Add 2, add 2. So now you have 15, x plus 6 is equal to 77. Does that look familiar to you, like the previous problem? So now you're going to put log base 15 of 77, notice I put parentheses around it, equals x plus 6. How do you solve for x? Subtract 6, subtract 6. Okay, so let me show you guys the button that you want to use when the base is not a 10. You ready? I always forget. Alpha window? Yeah, alpha window. See number 5. Just like that. Okay? So the button for this one is alpha window. Okay? There you go. Alright, so alpha window, base 15, right click over, 77, right click out of it, minus 6. Okay? So x is equal to, okay, 39596. Well, let's round that correctly. Negative 4.3960. Okay? But if you put 1, 2, 3, 4, I'll give you credit. All right. Notice you have to isolate the base to the power. Okay? All right, let's take a look at the next one. Do you see how the k is in the exponent position? You need to isolate that one first. So to do that, what do? You divide both sides by 3. So 10 to the negative k is equal to 34 divided by 3. Just keep it as a fraction for now, okay? Rewrite it as a log because you're solving for exponent. So log base of 10, base 10 of 34 over 3 is equal to negative 1k. divide both sides by -1, because you're solving for k, and you just type that in. See how it's a base 10 already? You can do I think it was alpha window, wouldn't it? Yeah, alpha window. If not, the base is already 10, so you can just use this button right here that says log, okay? Parentheses, 34 divided by 3, divide by -1, not -1, -1. So x is equal to -1.0544. Okay. Well, that looks terrible, doesn't it? Let me rewrite it. -1.0544 equals k. Yeah, that looks better. All right. There you go. Okay? This is only part 1. Make sure you know this and know this very well. Solving is 50% of the test. All right. So make sure you isolate your base with your exponent first. Okay. So there's your assignment. Okay, keep in mind, isolate base with exponent before you rewrite it, and you can also change of base using this paper right here. And I will upload this paper into Google Classroom. Thank you. Miss